Recognizing that sometimes is half the battle. All right, here's number 1 and 2.
Decreasing it.
Wait, why? Why minus 4 negative?
Because the absolute value of y minus 4 is negative y minus 4. Because your initial condition, check this out, your initial condition, which is 3, if you were to plug that in right there, 3 minus 4 is negative 1, and the absolute value of a negative is the negative of that negative. Does that make sense? Number 2 is pretty tricky. You've seen ones like this before. I mean, the whole absolute value of y minus 4, there's definitely some things to think about. Can I answer for you on number 1 or number 2? Any questions, concerns? Allie, what do you think about this? Sorry. Hey, show me a hand if you're thinking about 1 and 2, or need a little more time with 1 and 2. Yeah, we're going to get to 3. I just want to make sure we're good with 1 and 2 before we do 3. Cole, you getting it all figured out on 1 and 2? Okay. Is it okay if I scroll? All right, here is an answer for number 3. Like the thing, x plus 2 plus 3. So I would type in like x plus 2 squared plus 3. Squared plus 3. The other one, negative 5 seconds.
Oh, it's minus 2.
You just go do zoom 6.
Yes,
Literally our first practice together. Camera on the goal.
Catherine, you have a paint expression. What's up?
We're all pretty good.
So what
You mean like hundreds?
Not a close answer, but probably some little detail. Well, so here's something I'm noticing. The extra set of reps here because 7 minus you want to see the whole yeah. There we go. Oh my goodness. Big numerical difference, small detail. Because you basically needed just 10, yeah, so 10 was just 10 versus 4. Yeah.
Everything that the seconds.
Yeah, I wanted to.
How do you do the line?
So guys, questions on 3? Questions on 3? Science. That's either really good or really bad. Either you got it all mastered, or you feel like you have not. Or you're tired and lazy. I don't know.
You have to do 7. Why do you have to do 7?
So the axis of rotation is not the x-axis or the y-axis. So it's been displaced. The axis of rotation is y equals 7. So to find the appropriate distances, you need to do 7 minus. Did you watch the video of me today?
Yes.
It's in there. I'm not going to go back and reteach that right now.
It's okay.
The short answer is it's how you find the radius. The bigger answer is in the video. We did it with like pictures and such. The really quick answer is you always do axis of rotation minus the appropriate function. If you just want to formalize it, which I'm not a big fan of, that's what you do every time. Get the right radius. Hey! Oh, you need it like 413. So you can't make recount. So it's 7 minus. I'm going to subtract this whole thing.
Instead of flashing,
The way you have to set up your part of this. So it's really 7 minus minus 30, like if we just minus 7.
That's what you say in like actually.
So if you type it in exactly what you type it Okay, ladies and gentlemen. So now please, hey, you guys ready to finish? Like, literally finish the new stuff? Like, we're gonna practice this tomorrow, but literally, this is the last of the brand new stuff. Okay? Who knew you were gonna make it all the way here? Kind of cool. So I have a little demonstration for you, but before I do, I just kind of want to lead into this a little bit. We've found volume for the last several days, right? And all of the volume we found has been based on a region rotating around something, right? Creating like this donut, bowl, solid sort of shape, right? Depending on the nature of the region. So we're going to find volume again, but it's going to be based on something different. It's not going to be based on rotation at all. Okay? Not going to be based on rotation at all. I want to show you a little demo of this and see what you think of this right here. Yeah, that's about where I want it. Okay. So what we have here is I know I've got this great educational opportunity, and the only thing you can see is he has a lot of tabs. We didn't notice the important stuff. I'm busy, and I don't want to forget my stuff. So here's what I want you to notice. The graph on the left is drawn in classic graphing form, right? Like you're looking straight down on the x-axis and the y-axis. That's like what you've seen since like 9th grade, right? Or 7th or 8th grade, or whatever it was when you first learned how to graph stuff like this. The graph on the right, I would say, is drawn like in a 3-dimensional perspective. You see the gray plane? The gray plane is the xy plane. It's the thing that we're looking straight down on. In fact, if I did this, can you see how it's the same? The gray plane is the xy plane. But if I take this and I tilt it to be in a little more of a perspective drawing, can you see how the gray plane is now, instead of looking straight at the piece of paper, now we're kind of looking at it like at an angle? Make sense? Okay. So in this little demo, there's going to be no rotation, no pi necessarily, except in one case. There's no rotation at all. We're going to create this solid using what we call cross sections. And the way that I like to think about cross sections are things that just like grow right up out of the ground, with the ground being the gray plane. So check this out. See if you can get my analogy here about something growing out of the ground. So, check this out. I'm going to grow, are you watching? I hope you are. I'm going to grow a square right out of the ground, like so. If that gray plane is the ground, you see how the square is just like growing up like a tree right out of the gray plane? What does this mean? Well, you see how the square's side is defined by the red and blue graphs? Like the side stretches between them? In fact, if I were to do this, you see how we're now looking straight down on the square? All we see is kind of that top edge of the square. Looks like a line segment, but then when I put it in perspective, I can see it's actually a square growing right up out of the ground. Or a fence, whatever little analogy you want. Make sense? So how do I make a solid out of this? Well, what if I had more than one square? What if I had like 10 of them? Can you see a solid starting to take shape? If I wanted this to actually be a three-dimensional solid that would displace water or whatever, I could add a few more cross sections. And then I could add more. And then I could add tons of them, like 100 of them, and now I get this lovely solid. Can you see it? Oh, it's laggy and choppy. It's so smooth on my computer here. My screen is good. Can you still see the base region? Looking straight down at the base. Now we're looking at it in perspective. Some squares have grown up out of that base region. Did you notice there was no rotation at all? In fact, if I kind of play this back, do you see how nothing is rotating to create the solid? I'm just growing more and more and more and more squares to fill in all the gaps. So if I was going to totally fill in all the gaps and have a perfectly formed solid, how many of those square cross sections would I have to have? Right, and how wide would each of those be? AKA approaching 0. In this case, yeah, it'd be a dx. You're right, it'd be a dx width. Okay, so can you visualize this a little bit? I know the computer helps. What if I did not want to grow squares out of the ground? What if I wanted to grow triangles? Maybe it would look like this. Can you see how now instead of square cross sections, they're triangles? It's the same base, right? Base hasn't changed. But now instead of growing square cross sections out of it, I just grew triangles. And of course, I can make the number of triangles go up, up, up towards infinity, same base region. And now it's kind of this mohawk looking thing, or maybe it looks like a dinosaur, like the back of a dinosaur or something. I don't know. Looking straight down on it from the bottom, the sides. By the way, this is all just GeoGebra. You could click the link, from your own package. You can go and do all this stuff like I am. Hey, what if we didn't want something with sharp corners? What if we wanted semicircles? What would that look like? Look like this. Can you see all those semicircle cross sections? Sir. Efficient. Circles are always most efficient, right? But with this, if you think about it, wouldn't just like the taller cross section have more volume? Like if the goal was maximizing volume, then you just want like the tallest possible, but it could actually extend out from it. The maximum, there would not be a maximum because you could just keep making the region, like the cross sections bigger and bigger. If you wanted to minimize surface area and maximize volume, the circles would do it. Yeah. What do you guys think? The whole point of this is just visualization. Can you see what these solids look like? Hopefully the computer helps. If I filled this all the way in, I don't know what that looks like. Sort of like a submarine, I guess. Like a submarine that's just like half submerged. Doesn't have a tail though. Usually don't they have like a tail or tower or something? Anyways. Like so. Okay, so we're going to find volumes of this and then we're going to be done. Fair enough? Okay. So let's do this. So you just saw the high-tech version. Now you're going to see the low-tech version. If I have a region like this and I'm going to try to grow cross-sections out of it, what I am not going to do with this is I'm not going to be rotating anything around anything. That region is just going to stay right there. Instead of rotation, I'm going to be growing cross-sections out of this. So I could grow rectangles.
That's too high tech for drawing for me. No, I'm dead.
I mess these up on a regular
I was
basis.
just
Don't
gonna say
worry.
we can do this.
It's really confusing.
This is why I showed you on the computer. So it could be rectangles, it could be triangles, it could be squares, it could be lots of stuff, right? You just saw an example of 3 of them. Here's a 4th one. So here's what I want you guys to think about here is how do we actually find these volumes? Let's go back to what you said earlier. How many cross sections would I really need to fill out the solid completely? And they would have to be really skinny, right? Approaching 0. So how is it that I add up an infinite number of really skinny things?
Definite interest.
I have to use the integral, right? I've got to use a definite integral. So here is how you would find the volume. Volume equals the integral from a to b of a of x dx. So if the cross sections are perpendicular to the x-axis, this is kind of like how it is rotation. If we're perpendicular to the x, we're going to use dx. If we're perpendicular to the y, we're going to use dy. So if we happen to have cross sections perpendicular to the y, the formula is exactly the same. It's just that everything is going to be in terms of y. So the integral from c to d of a of y dy, they're essentially the exact same formula. Just one of them is in terms of x, the other one is in terms of y. So you all know how to handle integrals really quite well. You know about the dx and the dy, but what on earth do you think the a of x or the a of y stands for? Area. Well said. So is what the a is area of the cross section, area of each cross section. So let's think about what that could mean then. Doesn't that mean that a is very adaptable? So for example, if the cross sections are triangles, what do you think a would need to be? 1/2 BH. There you go. What if the cross sections are squares? Don't do BH, be specific. Not XY, not LW, something squared. How about side squared? Yeah. So I would just go side squared. Now, the B times H, the L times W, those are all obviously would get you the correct answer, but I want the most efficient formula, the most efficient method would just be side squared for a square. What if, like in our little demo, we saw a semicircle cross section? Not just pi r squared? 1/2. I think I heard that somewhere. Yeah, 1/2 pi r squared. What if I did have a tall, or not tall necessarily, but just some sort of a rectangle? Say again? LW, base times height, some version of that. So I think I'm going to put BH because I think base is kind of a nice concept to be talking about. There's all kinds of other area formulas that could be used here. You could have like cross sections that are hexagons or pentagons or all kinds of crazy stuff. We usually stick with the real basic stuff. Like these would be the ones you want to have memorized. That makes sense? If you got these memorized, you should be in good shape.
It got him down.
Good, good, good. Okay, so we got 2 examples. Here they are. Hey, for those of you that tend to jump ahead a little bit, please don't jump ahead to number 2. Number 2 has a little typo, and I want to give you a graph for number 2. hang on. Hey guys, listen up please. This is a good question for the group. Listen, Brendan just brought up a really good point. It's worth talking about. He noticed that on those two formulas I gave you, he said, wait a minute, there's no pi on the front, like in front of the integrals. And he's basically saying, is that right or not? So what do you think? Why isn't there a pi there? There's no rotation. That's right. So volume by rotation will always be some version of pi r squared. What would be the one scenario where you would have a pi with cross sections? The semicircle, right? So if you have a semicircle, the pi r squared over 2 is just going to naturally be there, but the pi out front would only come from rotation. Yep. Okay, great question. So this one says, find the volume of the solid formed with cross sections perpendicular to the x-axis that are squared. The base is enclosed by those two graphs. Now listen, if you graph these, I hope you're listening, really do. I'm trying to eliminate confusion. If you graph these two graphs, you're actually going to find two regions that are enclosed by these two graphs. I want you to pick the one that's closest to the origin. Okay, that makes sense? So please pick the one that's closest to the origin and then use that region with square cross sections and use your calculator to come up with a final answer. I'm going to just be quietly sketching the graph up here. You can either work on your own or you can watch me. Either way is fine.
So pick the one that's closest to the origin.
Yep. Yeah, there's two slivers of region that are enclosed by these. Get the one that's closest to the origin.
For these intersections, should we round our decimals?
I wouldn't.
No.
I would just include the whole decimal in your final calculations and then round at the very end.
Okay.
Is the second one, does it extend up here? Because I only see one.
That's the only, yeah, the other one, eventually the exponential gets steep enough where it catches back up with the parabola. But yeah, we just want the one that's close to the origin there.
Yeah, you just.
Hey, there was one other thing we talked about yesterday. I just mentioned briefly at the end, and it was to the obviously the non-seniors, and I just was talking about, classes to consider for next year, and I just said basically, if you're thinking about BC, like I consider you all like approved.
Okay.
So if you're thinking about signing up for that, and they ask, does your teacher approve this? The answer is yes.
Okay. Well, thank you.
FYI. So let's see. I was just peeking over your shoulder here. So I can't remember if those are the right numbers. They probably are. Why did
Do
you?
they need to be squared?
Well, so the cross section is squares, and you're subtracting. I can see.
It needs to be squared too.
I think. Okay. I think I see the issue. Here's what you need to do. Like I would just say like integral side squared. Like just one big set of parentheses side squared, and then I want to think about where does the side length come from? Because I don't think this is going to work.
Okay.
Does that make sense?
Yeah.
So I would kind of build it the same way we build the washers. Like I'm just
Yeah.
going to put my basic structure in place and then fill in the details instead of trying to do it
That
all at
makes
the same
sense.
time. I'll kind of present it that way here in a second. I've got my picture up there with one little representative cross section.
Which would actually end up being the same as you're squaring it, but
Yeah, if you do low minus high or high minus low, in this case it doesn't matter.
Do you square the whole thing or do you square each one of them?
Well, that's a great question.
because the side, it's side squared and the side is
that,
the
yeah,
function.
I-
vice
Yeah,
versa.
and if you squared each one of them, you can't do that, right? You can't say that x plus y squared is x squared plus y squared, right? It's different. So I'm going to show you like kind of a way that I build these to try to avoid having to deal with questions like that, or at least knowing the answer to it ahead of time.
Okay. 3.18.
Okay, so here we go. I've got a picture up there. Does this picture make sense? So here's how I would approach this. When I see cross sections that are squares perpendicular to the x, listen, you guys are all capable. I'm just trying to prevent you from making frustrating errors, okay? The ones that you should just know better. So here's what I would write. As soon as I read all that, maybe I have the graph in front of me, I would write volume equals integral side squared dx. That's where I'd start. Because I know that the area formula for a square is side squared. I'm putting that big parentheses squared, and I know it's perpendicular to the x, so I'm writing dx. Where am I going to start accumulating?
1.211.
That's the intersection point, right?
Yes.
Okay. And then where do I stop accumulating?
3.977.
And again, that's the intersection point. You guys all with me?
Yes.
You guys good? Okay, cool. So then side squared, I'm going to highlight this on my graph with a yellow line. Isn't this my side length right there? And isn't the side length determined by the blue graph and the red graph? Well, how do I find the distance between the blue graph and the red graph? I just subtract. That's right. So all I have to do now is figure out which one's higher, and it is the exponential, at least for this region. So I'd go e to the 0.4x minus x minus 2 squared plus 1. And as long as I get that in the calculator right, I should get the exact right answer. Anybody want to volunteer what they got for an answer? Decimal-wise? 3.180. You know what? That is what we got in the other class too. So 3.180, I think, is how that one turned out. You're really careful with your roundings. I would not round early if I were you. Okay, so here's what I want to do for you guys on number 2. But before I do that, are you doing okay with number 1? So number 2. So first of all, it's just really baffling to me. I did a little minor edit, and all my stuff is the same, but somehow the stuff that ended up on Schoology is a little bit different. Will you please double check and look at that second function and see that they are weird different, right? Please change to mine, okay? Please change to mine. The other thing I'm going to do here for you is I'm going to give you the graphs. I'll graph it in classic form here, I guess. The first function, the one that I think we have is the same. What kind of graph is that? It's a parabola, but doesn't it open sideways? Which way does it open, right or left? It opens left, and it's shifted one up, right 4. Yeah. So 1 up, right 4. Hey, if you're freaking out about, am I supposed to know how to graph this? The answer is no. Don't worry about it. Okay, so this graph looks very parabolic. And then the other one is actually is actually an exponential, so it'd be x plus 10, e to the x plus 10 over 0.4. Oh, it's an exponential. It's increasing. So you can graph it real quick. It'd be it'd be e to the. I'll tell you what to graph. E to the x minus 10 divided by 0.4.
So what's this whole thing's obviously
Yeah, I'll just do it real quick. E to the x minus 10 divided by 0.4, 6. Oh, and it got shifted way right. Interesting. Trying to think about. So the other one looks like this. Like so. Something just seems off and I'm just not putting my finger on it. Let's just do this. Let's just make it super simple on ourselves. Let's do... Sorry, this is not turning out the graph that we turned out in the last class. I'm not sure what I'm missing. I know that that's right. We're opening left. Okay, let me just do a little quick rethink about what I want to do. Interesting. Let's just do this. Let's just think conceptually here for a second. Darn it. It's really bugging me. Hey guys, please, right now, please just don't talk. I'm trying to think, and that's not helping. Let's do this. I'm just going to kind of make up my own question on the fly. Fair enough? You guys agree with these graphs? As a mathematician, that makes me so sad. You look at it and you're like, well, gee, Mr. Anderson, I didn't have my calculator. I can't be expected to graph without that, right? Okay. There we go. What if we put a vertical line up there? Fair enough? Okay. And again, I wanted to get the perpendicular to the y-axis. So if this was our region right here, and we are going to have these isosceles right triangles with legs spanning the base that are perpendicular to the y-axis. Let's think about what that would look like. I'm going to try to give it a little perspective. Wouldn't these triangles maybe, look about, like this? I feel like that's a pretty good drawing. Can you see it? Okay, so there's some really challenging language in here. It says that these triangles are isosceles. So tell me about isosceles. How many sides are the same? Two. Equilateral is 3, right? So isosceles is 2. Okay, so they're isosceles. And they're right triangles, right? So they have 2 sides that are equal. They got 1 right angle. And then it says this phrase right here, with a leg spanning the base. And aren't the legs of a triangle, of a right triangle, the 2 non-hypotenusae? They're not the hypotenuse? It's a new word, yeah. So here's what I would say. These sides that I'm marking in orange, they're congruent, aren't they? This side here and this side here. Basically, the sides spanning the base and the height. All those sides should be the same length. That makes sense? So here's what we would do. The cross sections are triangles, so I'm going to write volume equals integral of something. Would it be a dx or a dy integral? Why? We're perpendicular to the y. Yep, so we're going to use dy's. dy. Then my limits of integration, I'm just going to fudge these here because if we had them, we'd be able to put the numbers there. What I'm going to say here is that this intersection point is y equals a, and my purple line up there is y equals b. So wouldn't I accumulate these triangles from a to b? Okay, so I'm going to accumulate from y equals a to y equals b. And then what do you think my integrand would look like? 1/2 BH, that's right. And we're going to adapt this a little bit because with this, the way these triangles are arranged, isn't the base the same as the height? So I could just write this, I suppose, base squared or height squared, depending on how you want to word that. The final question would just come down to, how in the world do I find the base of the triangle? That's the last piece of the puzzle. It's subtraction. Would I subtract high minus low? Right minus left. Yep, the other way around. So it'd be right minus left. So it'd be red graph, which is this one. I didn't leave myself much room. So right graph minus left graph. And I've got it. So if I knew my A and my B here, which we could figure out easily, especially if I gave you the B, then plug it in the calculator and you're done. Can you tell that I just want you to get the concept? I'm assuming you can do Math 9. I'm hoping. I just want you to get the concept. Yes?
You don't do anything with the intersection point on the left.
I would not be able to do that, but
Intersection of which two things? Oh, the purple and blue? No, because we're going to accumulate from bottom to top. So the B would just be where I stop accumulating.
So you don't need, wait, could you technically use either the blue and the purple or green? Because they're the same height versus y.
For my B value? Yes. It'd be the same height. Yeah. Either, but I would have already given you the B, so yeah. Hey, let me hand back your quizzes on the way out. Okay, you guys can pack it up and go. You have a good rest of the day.
Is it quizzes or tests?
So I'm going to hand you back the quizzes to take. I still have the test. I just ran out of time with the little wrap screws there. Ben, I've got yours. Anna, I've got yours right there. These are your quiz 19s. There you go. Cole, thank you, Duho. Brennan, I've got. Will is right here. Brennan is right there. Cole, there you go. Grant, there you go. This is all working out. Besides, is here. Thank you. See you, Aaron. Tyler, I've got you. Allie, you. And great timing. You found a bunch of volumes. Basically, you found volume. And only one of you area. That was the main issue. Kindle.
Oh, is this 19?
This is quiz 19.
So can I take this tomorrow?
There you go.
I planned with you to take it yesterday, but I forgot about this week.
Taking quiz 19.
Tomorrow, when?
Today or tomorrow? During tomorrow lunch.
Okay. Your open periods.
I have gray and red off. And then I could come in early or lunch or after school or skip a class.
Did you have quiz 19?
No, I need to take it.
Okay.
And I have Navy off tomorrow.
Thank you, Brendan. Thank you.
Thank you.
Tyler.
Or I could take it Thursday.
I'm going to say, so the connection will be here at 7:45
Tomorrow.
tomorrow. So I'll be here at 7:45 tomorrow. So I'm going to say connection into Navy.
Okay.
But stick around because I don't want to administer this quiz like 6 different times. I'm going to try to be efficient here. So you are going to do it, and you're going to do it. No, quiz 19? Yes. So talk to me.
Does lunch work tomorrow?
Does lunch work? Oh, man. Yeah, if we do 12, let's do lunch then.
Okay.
Let's do, because I hate having to administer a quiz like 9 different times, so I'm glad you're all here. This is lovely.
Yeah, anytime next week.
Yeah.
We love that.
Lunch then.
He does not love
Lunch
that.
tomorrow?
Lunch tomorrow, like, give
He
me
went
time
all
to run down and get my lunch.
Yes.
It'll take 10 minutes, I'll come back up. The quiz will take you 20, 25 minutes.
Okay.
Awesome.
So
Tomorrow
that'll be
lunch.
plenty of time.
Thank you.
So,
A million
The
hours
videos.
of videos last night.
million hours.
From
We'll-
DECA yesterday.
DECA.
Sure, yeah, for sure.
I just have my quiz 19.
You sure can. Sorry I forgot to handle those facts, that's what I'm doing. Go ahead, Grant.
Can I do my quiz, like, I think it might be 16 day ones tomorrow? Because we're still making up the ones from the past test.
Sure. Sure.
Alright, sounds good, thank you.
Hi. I don't have a ton of time because I've got to get to the STEM thing,
Oh, we have to go. Okay.
so I don't know how long you wanted to talk.
Just like a couple minutes, if that's okay.
Go ahead.
So I've been really struggling lately, just like with anxiety, and I don't even know what it's from or anything. Just been having a hard time with it this week. I just wanted to let you know I'm in the loop and everything, and I'm trying to keep up the best I can. My grade obviously is not.
You're missing a test.
I'm missing a test and stuff, and obviously that's not helping anything. Would it be possible to move my test to Thursday morning? Are you here?
When on Thursday morning?
Like connection to grade?
So I'm here on Thursday, I'm here till 8:30 for the morning. So you wanna start, you have to start at 7.
Okay.
You
Okay.
can, I'm saying
Okay.
you can, but if you show up at like 7:30, cause you know,
Right.
whatever, you slept in.
So 7 to 8. How long does it take?
So the
How long do you
test
guys
itself,
like?
everybody got 80 minutes.
Okay.
So that would give you,
Okay, so start at 7? Okay. Can we do that? Okay, let's do that. That would probably be good and be better. And then I'll come in, cause I'm really confused on this unit, really. I'll come in.
you checked out the videos?
Yeah, I'm working on working through them the best
Yeah,
I can.
the one that I posted on Monday that was like, it's not even really in a
Yeah.
folder. That's a really good one. That
Okay.
piggybacks up what we did on the previous Thursday.
Okay.
And we just did a lot of practicing, so it's like 15, 20 minutes of just us practicing.
Okay, that'll be really
So hopefully
good.
that'll help.
Yeah, for sure.
And it's
for
just
sure.
right out of your packet.
Okay, sounds good.
Okay,
Thank you so much,
Thank
Mr.
you.
Anderson. I really
you
appreciate it.
betcha. Thanks for letting me know.
Yeah, thank you.
Okay, so I need